Welcome everyone, I'm Paulien van Alst and I'm going to talk to you about the Kotlin ecosystem at the backend side today. So welcome. First of all, I'm going to talk about who I am. I'm Paulien van Alst, as I stated, and can be found on Twitter under this Twitter handle. I'm a software engineer at Open Value here in the Netherlands. I'm from Utrecht actually. I'm a co-host at the Barcoding podcast. Together with my colleague Arnoud Rijpkema, we are talking about our day-to-day experiences on the job, about software engineering, of course. You can find us on Twitter as well, confusingly on the Twitter handle coding_bar. I'm in love with programming, so I'm really happy I can do this all day long. And I'm a Google developer and expert, Google developer expert in Kotlin as of September from this year. So what are we going to talk about today? There's a lot to talk about Kotlin backend side, but just for today, we're going to talk about why we should even write or build a backend in Kotlin actually. There are some challenges if you're coming from the Java world. We are here at JSpring, so we'll assume that lots of you are coming from the Java world, and you will see that either coming from the Java world as a developer or integrating Kotlin into a Java application will have its challenges. Still, you have no worries. You will have full benefits of it as well. That for sure. And yeah, where to choose from actually? You can integrate Kotlin right away into your Java applications, but Kotlin is not only its language, it's an ecosystem as well. So there's a lot to choose from in the Kotlin ecosystem. Think of your application framework, for instance. Do you want to go for the industry standard Spring, which is also hopping along with the Kotlin train, or do you want to use another one? HTTP library is the same. There are some standards, but also the Kotlin world is developing its own HTTP libraries, which will actually give you the full power of Kotlin as they're written in Kotlin. Dependency injection, there as well, there's something to choose from. And of course, your database libraries. So why even build a backend in Kotlin? Kotlin is an Android language, right? For only suitable for mobile development? No, it's pretty suitable for backend development, if you ask me at least. If you're hopping on the Kotlin train along, if you're developing your application in Kotlin, then you will have full advantages of its language features, which enable you to write a maintainable and readable code base. And that's really, really awesome. Less boilerplate code and still having more explicit code. In my opinion, I can express myself through Kotlin a lot better than other languages. Concurrent programming. Kotlin is also known for coroutines, where you can do some multi-threaded or at least reactive programming. And yeah, that's an awesome language feature that no other language in the JVM world at least can beat. And lightweight applications. Lightweight in code, lightweight in startup time, for instance. Lightweight in a lot of senses. They are Kotlin applications. And the use of DSLs. I think writing DSLs in Kotlin are very powerful. You can finally write a DSL in your domain, expressing the domain in a readable way, such as that non-programmers can understand it. And that's really powerful, actually. But the ecosystem also goes along with the language. Kotlin is not only tied to the language itself. There's a whole ecosystem that goes along with it, and it's really powerful. So challenges coming from Java. There are challenges still. It's not a holy grail, of course. So let's have a look at that. Java frameworks are using a lot of reflection to make everything work, and that's fine because they make things work. But with Kotlin, it clashes sometimes. Kotlin embraces immutability. It wants its objects to be immutable. But using reflection, sometimes you want objects to be mutable so that you can use reflection along as time and data comes. So that can feel sometimes a little bit awkward, but still frameworks using reflection are also looking at Kotlin, so this problem will solve itself. Proxying classes versus final classes. By default, classes in Kotlin are final. If you're proxy classes, you don't want them to be final. So it's something to keep in top of your head, top of your mind. And then nullability, of course. If you're developing in Kotlin, you need to be aware of the fact that you need to make a type explicitly nullable. If it's not declared as being nullable, the variable can't be instantiated. It can't hold the value nil. And that sometimes clashes, especially when you're developing against Java APIs or developing with Java libraries. So where to choose from? There's lots to choose from. There's, of course, as I stated at the start of the talk, dependency injection, database libraries, HTTP libraries, and application frameworks. So let's dive into it. Dependency injection. Well, one which will pop up if you Google dependency injection in Kotlin would be Dagger. Dagger is widely used at the mobile side of the Kotlin development, and that's why you will find it into your research. I'm not that experienced with it, but I will still mention it so that the image is complete. But there are also other alternatives. Coin is one of them, and of course, Spring. I will mention Spring a lot during this talk because Spring is an industry standard, and Spring is looking at Kotlin, and it's a very valid candidate in the Kotlin ecosystem as well. So not everything is new. You can still remain into your comfort zone of the Java world and still hopping on the Kotlin train. So that's good to know. So Dagger, what's Dagger actually? As I said, it's widely used in the mobile development. It's based on Java EE. So when you're looking at documentation or Dagger code, you will recognize a lot of them if you have done some Java EE stuff. So the @inject annotation, for instance. It does code generation during compile time. So all the classes that you will annotate will be generated during compile time. And then you have some compile options to speed that up, right? Because code generation means longer compilation times, but it's pretty tweakable. So you don't need to worry about this generation. But as I said, I don't know Dagger that much, so I will dive into Coin right now. So Coin is really Kotlin native, and it actually uses interfaces that will allow you to choose which implementation strategy you want to use. Why would you even want to choose between implementation strategy? Because Coin enables you to organize your dependencies using modules. So it's pretty powerful. And if you're used to work with dependency injection, you will recognize those codes as I stated here, which Coin knows pretty well. Well, let's have a look at some Coin code. Here I have a recipe service which depends on a recipe repository. Both are beans in my applications. I both want them to be injectable. So the second piece of code is a piece of code where I configure my application. It's an example of a Ktor application actually. Here I declare that I have my module, which will directly be created as the start point of my application. So I can be in control when and where I want to declare my beans. And then I declare my singleton recipe repository as this, and then I state that my recipe service would depend on a recipe repository, any bean of type recipe repository, out of the constructor. And then I want to use that, of course, because declaring my beans is one. Then I need to be able to use it as well. And here I have a routing block. A routing block in Ktor is a block where I can declare my entry points of my applications. I'm declaring here post under the URL recipes, and I'm injecting here a recipe service using the keywords by and the inject function. So that was Coin, and as you've seen, Coin is Kotlin native, so it's also using Kotlin language features. So that's a big advantage. Then let's have a look at Spring, and there you will see that is more still more Java-like. So it's annotation-based. Spring beans are not final, which means that you need to declare them open. And here I say it's testable. By testable, I mean that lots of testing frameworks are counting on Spring, which means that the integration with testing frameworks are pretty great. So that can be a big advantage here. So let's have a look at a piece of Spring code. Spring will do a lot of stuff using annotations, and those annotations will, during startup time of your application, will tell Spring what to do, what to instantiate, what to start up. And this is an example of it where I tell Spring that it is a Spring Boot application, and that I'm enabling in this example some reactive repositories. I can then declare my beans as being open and being a simple component using the component annotation. But I can also use some much more documenting annotations such as repository, which indicates it's just a database database repository class, or interface in that case. Now, let's have a look at HTTP libraries. There is some to choose as well. HTTP4K is the first one. HTTP4K is a lightweight application lightweight framework that you can use in your application. Full Kotlin. Ktor is an application framework, and it comes along with HTTP client. And then the Spring REST template. So let's start with HTTP4K. As I said, it's a lightweight framework, which is full Kotlin, which comes along with the Kotlin features. So it has extension functions, for instance. So using a full Kotlin framework will have its advantage on that part. And let's have a look at some piece of code. Here I have a fetcher, which uses a HTTP handler, which is the client, which you can inject using dependency injection, for instance. And I can just call this client with my request, which will return a response. So this is pretty straightforward. Then let's have a look at the Ktor HTTP client. It comes along with Ktor, so it will integrate pretty easily into your Ktor application. It's full Kotlin as well, and it will look like this. So there you have a client, which is, again, depending, maybe here the name of the class is not pretty suitable, but still this client will depend on an HTTP client, where I can do my request that I'm configuring using a code block. Oh, I'm going too fast. A code block where I say that my method is a get, for instance, on that URL. And when my status is successful, for instance, then I will return the response. There you have some utility methods that can be very useful. Now, I already showed the slides in my a few minutes ago, but then last but not least is the Spring REST template or Spring HTTP client. Well, it integrates pretty well with the rest of Spring. It has solid deserialization or serialization of your requests and responses, and it will look like this. You can declare a bean called REST template, and then inject that bean in some client and just fetch it using a method on the REST template. So we had the HTTP libraries. Now let's have a look at the database libraries, the other part, the other side of the application. Expose is one of them, full Kotlin coming from JetBrains as well. Joke is another one. It's from the Java's world there, but it has Kotlin integration and Spring. Some points of attention still when you're looking at database libraries. Have a look at the query language, the DSL. Is it suitable for your needs? Can you express yourself? Coroutines, when you're using coroutines, you want to make sure that the library is reactive or asynchronous, for instance. Otherwise, your application is reactive until the point that it is communicating with the database, and it would be silly. So let's have a look at exposed. Exposed will offer you a DSL, which is supporting database dialects, PostgreSQL, MySQL, Oracle, and much more. So it's pretty mature on that part. Exposed will look like this. This is a piece of code of a Cato application again, but I can configure it using code. So it's pretty expressive, where I can just say connected to my database using Hickory, and I want to, in a transaction, I want to create a recipe table. So I can also do my database mutations into my application configuration. And then if I want to build up queries and work with my database tables, I can, at the latter part of the code example, declare a table, which in this case has an ID of type integer with the name recipes and has 2 columns. And I can then declare a class representing each single row in that table, which looks like this. So a bit boilerplate code, would say. But then I can start using the DSL, inserting, for instance, some data into my table using the insert block, or retrieving some kind of recipe by name using those methods. So that would feel actually pretty natural. And then let's have a look at joke. Joke, never know how to pronounce it. It's from the Java world, but it has some Kotlin integration, but it doesn't have a DSL. It's much more of a chain of methods calling themselves. Then let's go to Spring. I haven't used joke as much, but I think it's a pretty good example to show to you. Let's have a look at Spring. Spring is more annotation based, so I can declare a table like this using a table annotation, and where I will declare my ID here along, and then repositories using the repository annotation. And in this particular example, is pretty cool. Spring is integrating with coroutines lately. So here I'm using a coroutine CRUD repository, which will return a flow of recipe rows in this example. So there you go, full reactive. Application frameworks, last but not least, Ktor, Micronaut, and Quarkus. I'm sorry if I offend anyone by putting them on the same row, but both are hopping on the Kotlin train as well. I will show Micronaut because I worked a bit with it, and not Quarkus, but you can assume that Quarkus will have the same kind of support with Kotlin. GraphQL, if you want to do some GraphQL things with Kotlin, will work as well, and Spring, of course. Ktor, let's have a look at Ktor. Well, it's pretty lightweight. Your application will start up pretty fast. Configuration through DSL. I showed a lot of pieces of code which were representing application configuration all through a DSL. It can only be used with Kotlin as it is full Kotlin. And this is how it looks like, how you can configure your application. With your main method, so your booting method of your application, you can just connect to your database, to some initialization part of your database. The initialization from your database, you can do it using expose, as I just showed you, where you can say create my table, or you can use flyway. Flyway still works pretty well with Kotlin. And here I'm starting a netty server on port 8080, for instance. I need to configure modules that I want to boot on this application. Cater relies on modules as well. And my module here is, this is an example of the module recipes, where I decided there to configure also the content negotiation injection, for instance, and declaring all my endpoints of that module. Oh, that went too fast. A recipe endpoint would look like this. I can declare a route with a base path API, having a get method recipes where I retrieve all the recipes, for instance. Let's have a look at the micronode. With micronodes, you can use functions, implement functions instead of applications. It runs on GraalVM and it has a pretty nice micronode CLI. And in that CLI, you will see that you will have, this is first an example of code. Using that CLI, you can generate a full Kotlin application, actually, which will, looks like this. And where you can declare your objects in your function just like this. Here you will see some nullability, so it still looks a bit Java-ish. Spring Webflux and coroutines. I already showed you an example of a reactive database layer, but it goes along until the endpoints. So that's pretty cool, and it's an industry standard as well, which can be a very feasible argument to use Spring in an enterprise environment. And it's approaching Kotlin more and more, so that's, again, pretty solid argument. If you want to start a Kotlin application, you can just declare your boot class, configure your main function as you're used to with Java, and your classes, your configuration with the repository, for instance, will just look the same, have the same look and feel as it had with Java. So that might be a strong argument as well if you want to stay in your comfort zone or don't really being challenged during your application development. I mentioned GraphQL earlier is not so much of an application framework, but I really liked it. Actually, I worked with it, and it's awesome to see that HTTP4K has a GraphQL module. The Expedia group developed a whole Kotlin framework, Kotlin GraphQL framework. So that's really, really awesome. Just a small mention because I thought it was great to mention, actually. So let's summarize at this end of the talk. There's a lot to choose from. Your code bases will change, will have a different look and feel. That's just a fact. But I would say embrace the Kotlin system, as it will change for the better. Thank you, everyone, for your attention. This is the end of my talk. Are there any questions?